robot watches a human make a cup of coffee. It observes the movements, the sequence, the gentle handling of the cup. And then, having seen it only once, the robot makes a perfect cup of coffee all by itself. This isn't a scene from a Hollywood movie. This is a real demonstration from a company called Figure, and their humanoid robot powered by OpenAI, the same minds behind ChatGPT, learned to do this just by watching. For decades, we've been promised a future of robotic helpers, a promise that has always felt like it was perpetually 10 years away. But something has quietly shifted. The race to build truly autonomous, human-like robots isn't just a science project anymore. It has become a multi-billion-dollar sprint between some of the biggest names in tech. What we're witnessing isn't just another gadget. It's the dawn of a completely new kind of machine, one that could change the very fabric of our daily lives. But the question isn't just how they're building these incredible machines. The real question is, why now? Why are we suddenly seeing this explosion in humanoid robotics after decades of slow progress? The answer involves a perfect storm of technology. And to understand it, we need to look at how different these new robots are from everything that came before them.
When you think of a robot, you probably picture one of two things. Either a giant, clunky robotic arm in a car factory, bolting on a door with perfect precision, or a fictional walking, talking companion from a movie. For the longest time, those were our only two realities. Industrial robots are incredibly good at doing one thing over and over in a perfectly controlled environment. They're powerful and precise, but ask one to do a different task or even just to pick up a part that's been moved an inch to the left, and the whole system breaks down. They are the ultimate specialists. On the other end, the walking, talking sci-fi robot has remained just that, fiction. The complexity of creating a machine that could navigate our messy, unpredictable world was simply too great. But companies like Figure, Tesla, and Boston Dynamics aren't building single-function machines. They are aiming for something far more revolutionary: a general-purpose robot. A robot that can be a factory worker on Monday, a warehouse stalker on Tuesday, and maybe one day, a helper in your home on Wednesday. They aren't just building a tool, they're building a platform. The goal is a robot that can learn and perform a vast range of tasks, much like a human can. This shift from a specialized tool to a general-purpose platform is the single biggest leap in robotics in half a century. And the key to unlocking this general-purpose ability lies in a controversial and deceptively simple design choice: making them look like us.
Why go through the immense difficulty of making a robot walk on two legs? A task that is famously unstable and complex, when you could just put it on wheels. It seems counterintuitive. But take a look around you right now. Look at the height of your desk, the design of your door handles, the layout of your kitchen, the stairs that lead to your second floor. We haven't just built a world, we've built a world for humans. For a wheeled robot, a single step is an insurmountable obstacle. A cluttered room is a navigational nightmare. A simple tool designed for a human hand is impossible to use. A humanoid robot, however, is designed for our world from the ground up. With two legs, it can navigate the same spaces we can. It can step over obstacles, climb stairs, and squeeze through narrow passages. This mobility is critical for any setting outside of a perfectly flat, specially prepared factory floor. Then there are the hands. The human hand, with its opposable thumb and incredible dexterity, is one of the wonders of evolution. Replicating it is a monumental challenge, but it's essential. Humanoid hands allow a robot to use the same tools we do, to pick up a delicate object like an egg or a heavy box, or to operate machinery designed for human use. This combination of mobility and dexterity makes the humanoid form the ultimate jack of all trades. It doesn't require us to spend trillions of dollars redesigning our entire world just to accommodate our new robotic helpers. They can slot right into our existing infrastructure. But a sophisticated body is just an empty shell without a mind to control it. And that brings us to the real secret ingredient that has been missing until now.
The robot that learned to make coffee by watching a human didn't have its every movement programmed by a team of engineers. It learned. This is the critical difference, and it's all powered by the explosive growth of artificial intelligence. Figure's strategy is what they call AI first, and it's the brain, not just the body, that's causing this revolution. This AI brain is performing several miracles at once. First, there's perception. Using a suite of sensors, like cameras and lasers, the robot builds a 3D map of the world around it in real time. It doesn't just see shapes, its AI identifies objects, understands their properties. This is a box, this is a person, this is a delicate cup, and predicts how they might move. Second is locomotion. Walking is something we do without thinking, but it's an incredibly complex balancing act. The AI constantly processes a fire hose of data from sensors in its feet, legs, and torso, making thousands of micro-adjustments every second to stay upright, walk smoothly, and even recover from a stumble. But the most game-changing part is manipulation and learning. In the past, if you wanted a robot to pick up a box, you'd have to program the exact coordinates, the precise grip strength, and the specific arc of movement. Now you can just tell it, pick up that box. The AI looks at the box, decides on the best way to grab it, and executes the task. And thanks to new AI models, like the ones from OpenAI, these robots can learn in ways that feel like magic. They can learn by watching a human in a process called imitation learning, or even through spoken conversation. You can literally talk to the robot, explain a task, and have it reason through the steps to complete it. This ability to learn and adapt on the fly is what will finally allow these robots to leave the lab and enter the real world. And their first stop is going to be the global workforce.
One of Figure's primary stated goals is to solve labor shortages. Across the world, there are millions of jobs that are physically demanding, repetitive, and often dangerous. These are the jobs that are difficult to fill and have high turnover rates. This is where humanoids are set to make their first and most significant impact. Companies like BMW are already partnering with Figure to test deploying these robots in their automotive manufacturing plants. Imagine a humanoid robot working on an assembly line, lifting heavy components, or performing tasks in a cramped space that would be ergonomically challenging for a human. In the colossal world of logistics and warehousing, a single humanoid robot could potentially unload a truck, sort the packages, and place them on the correct shelves. They can work 24/7 without getting tired or injured, drastically increasing efficiency. This isn't about replacing every human worker, it's about augmenting the human workforce, taking over the tasks that are least desirable and most dangerous, and freeing up people to focus on more complex, creative, and problem-solving roles. It addresses a critical economic need for more labor in key sectors to keep supply chains moving. This is the first wave of deployment, industrial and commercial use. But the ultimate vision, the one that has been in the back of our minds for a century, goes far beyond the factory floor. The next step is to bring them into our personal lives. The holy grail of robotics has always been the domestic assistant, a robot that can handle the endless cycle of household chores. Figure's own website paints a clear picture of this future, stating that we should expect Figure to do dishes and laundry, unpack groceries, and perform other household tasks 100% autonomously. Think about the sheer amount of time that would free up in your life. Hours every single week that could be spent with family, on a hobby, or simply relaxing. Beyond just convenience, the impact on quality of life could be immense. For the elderly or individuals with disabilities, a humanoid robot could be the key to maintaining independence. A robot could assist with daily tasks, provide mobility support, and help with meal preparation, allowing people to live safely and comfortably in their own homes for much longer. This isn't just about washing dishes, it's about providing dignity and freedom. The same robot that can handle a delicate car part on an assembly line could one day handle the delicate task of helping an elderly person out of a chair. This is the long-term vision that is driving billions in investment. It's a multi-trillion-dollar market, waiting to be unlocked. But as exciting as this future sounds, we're not there yet. there are still some major hurdles to overcome on the path to this humanoid future. Building a robot that can walk and make coffee is one thing. Building one that can operate safely and reliably for hours on end in a chaotic home is another thing entirely. The first major hurdle is raw technology. Battery life is a huge challenge. These robots are packed with powerful computers and motors, and keeping them running for a full day without being tethered to a cord is a problem that still needs a better solution. Improving the fine motor skills of their hands to match human dexterity is another ongoing challenge. Then there's the cost. Right now, these robots are incredibly expensive, costing hundreds of thousands of dollars each. Their first customers will be large corporations that can afford the investment. For them to become common in our homes, that price needs to come down dramatically, which will only happen with breakthroughs in manufacturing and economies of scale. And finally, there are the big societal questions. The most obvious is job displacement. While these robots will first fill jobs that are hard to staff, there are legitimate concerns about their long-term impact on employment. As a society, we'll need to have serious conversations about how to navigate this transition. There are also critical questions about safety and ethics. How do we ensure these autonomous machines always make the right decision in a complex situation? These are not small problems, but they are the exact kinds of problems we must solve to responsibly integrate this transformative technology into our lives.
So we are standing at a genuine inflection point in history. The gap between science fiction and reality is closing faster than ever before. The slow, steady march of progress in fields like AI, material science, and battery technology has finally converged, creating the perfect storm for the birth of the autonomous humanoid robot. We are moving from an era of single-function machines locked in cages to one of general-purpose, intelligent partners that can walk and work among us. The journey ahead is complex and filled with challenges, but the destination is a world where human potential is amplified, where dangerous and dull work is automated, and where we have more time for the things that truly matter. The robot revolution is not coming, it's already here. If you enjoyed this look into the future, consider subscribing for more videos breaking down the technology that's changing our world. Well, like and share this video. Thanks for watching.